Alrighty, we've done a bunch like number 29 in the past, or over the last couple days. In addition, there's usually one of these in the study guide, so there's usually probably going to be one of these types of problems on the test as well. So I'd like to go through how to do it, just as a backup in case you're still having trouble. So the problem here is that I got two square roots. I can't just square everything because the middle term would become a mess. We've talked about that in class. You should know what I mean. I fully did out the solution the wrong way, and we showed why it wouldn't work. But so first thing I need to do is isolate one of the square roots. Doesn't really matter which one. I'm going to choose to leave the root 3x plus 1 on the right hand side, or on the left hand side, and then move the other one over to the other side. So I get 2 plus root x minus 1. Now I need to square both sides. So I'm going to do over here the work for squaring the right hand side. The left hand side, when I square it, cancels with a square root, gives me 3x plus 1. That's pretty simple on that side. This side, you need to make sure you do it all the way out, because you can forget pieces if you don't. So it's 2 times, it's 2 plus root x minus 1 times 2 plus root x minus 1. This gives me 4. This gives me plus 2 root x minus 1. So does this. Plus 2 root x minus 1. And then lastly, this times this gives me, notice it's root x minus 1 times root x minus 1, so it's root x minus 1 squared, which is just plus x minus 1, running out of space, that's a minus 1. So let me come back here. That gives me, well, I've got 4 and minus 1, so that's 3. Then I've got 2 root x minus 1, 2 root x minus 1, so I have a total of 4 of them. Minus 1. And then I've got a plus x left there. So now I need to collect the terms, and I'm going to move everything over to the left-hand side except for the root, so that I can square it and get rid of it just like I squared that piece to get rid of it. So I need to do that with this guy. So I'm going to move the other terms over. Subtract the x, I'm left with 2x. Subtract the 3, I'm left with minus 2. And then that's equal to 4 root x minus 1. From here, I'm going to scroll down and give it a little more space. From here, you could go out and finish it out with it looking like this, but it's good to recognize that everything's divisible by 2 here. So by dividing by everything by 2, I'm going to kind of make it easier to work with. So I'm going to divide both sides by 2. That leaves me with x minus 1 equals, the 2 only divides into the 4, doesn't divide into the other piece because they're being multiplied. If there was a plus sign right here, then I would have to divide the 2 into that thing, but since they're being multiplied, only divided into the 4. That gives me 2 root x minus 1. So from here, now I can square, just like I did that second line right there. I'm going to square both sides. Key here is that there's kind of 2 places where you can make a big error in this particular problem. You can make it here and not account for those guys, or I could not account for this. That 2 there needs to be squared. I'll show some work over here on the right. So I'm going to square both sides, square, square. Notice, if you need to write this out, that's fine, but I wouldn't really expect you to necessarily write this out. So when I square this side here, I get 2 root x minus 1 times 2 root x minus 1. Notice there's 2 2's there, so they get multiplied by each other. My answer is not 2 times x minus 1. As I multiply here, I'll do the left side out. I get x squared minus 2x plus 1. That should be easy for you. Now I'm going to write this piece out. Notice I get a 4. That's probably the easiest place to screw this one up, along with that other one that I underlined in yellow. So 4 times, I get root x minus 1 squared, so that gives me x minus 1. Scroll down. So I get x squared minus 2x plus 1 equals 4x minus 4 after I distribute that 4 in. Now, I don't have any square roots, so it's quadratic, so I solve it the same way I would normally solve a quadratic. So I'm going to move everything over to one side so it's equal to 0 and try to factor. So that gives me x squared minus 6x plus 5 is equal to 0. Now I've got to factor that. That gives me x minus 5, x minus 1 is equal to 0. And that tells me x is equal to 5 or 1. So, you may say to yourself, oh, I'm done. I got x equals 5, I got x equals 1, we're good to go. But you need to check. Sometimes one will work, sometimes neither will work, sometimes both will work. So I'm going to rewrite that equation. This is the original equation. We have to check it off the original equation. So I'm going to rewrite that down here so that I have a little bit more space to work with it. So that said root 3x plus 1, minus root x minus 1 equals 2. So I'm going to go through with my check, do it in orange. It says check. X equals 1. So that gives me root. So 3 times 1, I'm just plugging it into this equation right here. So 3 times 1 is 1, plus 1 is 4. And then into this guy, 1 minus 1 is 0. So root 4 minus root 0, well that's 2 minus 0, which is 2, so it works. It has to be equal to that. If it came out to be 3 or something like that, then I would say no, it doesn't work. Now I need to check the other one. X equal to 5. That gives me root. So 3 times 5 is 15, plus 1 is 16, minus 5 minus 1 is 4. So that's root 16 minus root 4, which is 4 minus 2, which is 2. So this turns out to be one where both of them work, which a lot of them, only one of them works. So since both of them work, that's my answer.